out. So we are recording this lecture and it will be posted right after we finish this class.
So did you send this Excel?
Beg your pardon?
Did you send the Excel to us or no?
That's a very good question. Thank you for asking. Thank you for asking. If you go to your Blackboard, so in this case, I use the one that I have used for other courses. So it's here. So this is the CI confidence interval class. So please download it.
I got you. Thank you.
Yeah, sure. So as you can see, I have been using this for some time. Well, this is from the spring 2020. This is fall 2020. So I have been, oh, sorry. Ooh, 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 ooh. I think it's a combination of cold and cold. So before I start, I was looking at this website. I remember when this website was free and was very good. Well, it still is very good. So if you want to learn anything and at some point you want to earn credits or some type of certificates, so this is a very good website. And I think now the cost is $50. So you pay $50 and you can take courses as you want. And that might be good. Some of them are classes, full, well, I guess in the case of the programs like masters or any other type of learning, it can be, you have to pay to the university. But some courses that are here, they used to be for free, now they cost money. So you can learn many things. For example, this topic of machine learning, very important. If you are an economist, you are going to be using big data. So and at some point, many things that you can learn. So you can learn languages like SAS. SAS is software that is kind of similar to Stara, the one that you will use next semester. So I think this website is very good. You want to, like some of them are free. I think I'm gonna take this one because I am very interested in COVID-19. So, and this is free. Some of them are free, and any of them is gonna be a very high quality course because they are taught by the best universities in America. So you can see this is Duke, Stanford University, Michigan, Yale, and many other universities. I guess this is Wisconsin. So I recommend this website. So if you have some spare time or you need to learn something that is going to be important in your life, I think this is a very good. It's a very good website. So I recommend this. At least you take a look and you see whether this can be helpful in your careers. So having said that, I'm gonna close it. So today we are gonna do the confidence intervals. So if you go to module 4, then go to confidence intervals, then you have the PowerPoints and you have the Excel file. I also, I mean, as you have noticed, I put some other sources. These confidence intervals, so those are videos. This is from the Khan Academy. Some of them are very good. Some of them are very taught by people who feel that they can do a good job teaching, and some of them do. So I upload them. So in all the chapters, you can see that you have additional resources that you can use. So as I said before, the goal of this course is to make life easier rather than make life more difficult. So we're gonna continue using Excel, and some of them I created. Some of these little programs I stole it from the internet. Well, basically not stole it, stole them because those are there, and I guess you can use it as you want. and is public access, but some of them are very helpful. That's what I have been doing, finding resources and at some point creating some that can be helpful. So today we are gonna look at what at this topic, confidence intervals. That's a beautiful topic. I think I have said that of every single chapter, but I really like this topic because you can. So we are we started last class with the introduction of inferential statistics. So now we are using samples and we are trying to infer that this sample resembles the population. So the question is, how sure are you that this sample reflects the population? Well, that's a very good question. And for that, we are going to use some statistics, some tools that help us build in certain degree. We are going to build some parameters or some statistics that help me confirm that my computations are within the parameters that we are analyzing. For example, if I choose a sample mean and then I want to see how close that is from the population, I think I can build a confidence interval. So that tells me that well, that's an indication that I am making some inference from sample, and I am projecting those values to the population. So so confidence intervals are extremely helpful. I just wrote a paper, and I don't know if I can just mention some of the things. So here, this is the results. So this is something a little bit different from what we are doing, but makes sense. So in this case, we ran a regression. We found some values. This is the values for COVID, how COVID was, or what are the factors that explain the spread of COVID. So in some cases, income, people, whether people are poor or rich, how likely is that they are going to be infected with COVID, whether they are minorities, meaning Blacks, Hispanics, how likely is that a Black or a Hispanic is going to be infected with HIV, sorry, with COVID. Also, how likely is that older adults, people who are old, they are more likely to die if they get infected. So what we learned here is those are the parameters that we estimated, but then we transform these parameters in something else that is called odds ratios. So in order to explain the odds ratios, we are using a 95 confidence interval. So that means that my parameter, for example, this one is 37, and my confidence interval is very wide. So that means that the degree of variation is very strong, but it still is a very good way to express that this 95% confidence interval. So in this case, for example, what we can read from these cases is that COVID is more likely to be spread when the household is crowded. So if you live in a house that is crowded, of course, your chances, the odds of getting COVID are 37 higher than those who live in houses that are not crowded. So we have the same effect for workers. This is 8 times higher the likelihood, the odds of getting infected with COVID if you work, for example, in a restaurant, you work in a place where social proximity is strong compared to those where you can work from home, like me, right? So and as you can see, we have these so-called confidence intervals. So what this confidence interval is telling me something that we are going to learn today. So so I want you to pay attention because this is very interesting. If you are working with people in health sciences.
Oh, could you pass me the charger for the laptop?
Hello? Hello? Okay. I muted everybody. Please, if you join the meeting, please mute your phone. So So confidence intervals are very important. If you're working with people in health sciences, very likely you're gonna find statistics that are more likely to include confidence intervals. So what we can say today is that we use data to make generalizations about an unknown population. So this part of statistics is called inferential statistics. So we are gonna take a sample, probably, I don't know what the value of the mu is, but I can make inference based on my sample and make a statement that makes me confident about how sure I am that my sample is within the boundaries of the population mean, right? So that's the idea. We don't know what is the mean, but I can tell you that I am very confident that these values are within the boundaries of my mu. So the sample data help us make an estimates of population parameters. So once again, we don't know the population parameter. In this case, I don't know the value of mu. So all I can do is to take a sample and make that inference. So for that, I'm gonna build a confidence interval that allows me to not say precisely, but with certain degree of confidence. So this is a very good example. Suppose you were trying to determine the mean rent of a 2-bedroom apartment in your town. So you live in New York, you want a 2-bedroom apartment, and the first thing that you do is that you open the newspaper and take a sample of apartments that are 2-bedroom apartments, right? So you might look in the classified section of the newspaper, write down several rents listed, and then you take the average of them, right? So some of them are gonna be very expensive, some of them are gonna be cheaper, depending on the neighborhood. So you are gonna obtain what is called a point estimate. So the best chance to make inference on the population mean is to find the sample mean. And this sample mean is gonna be called the point estimate of the true mean, right? Is that the true mean? Well, probably not, because if you open another newspaper and you find different prices, very likely you are gonna get an average that is different from the one that you previously revised. So you can have so many samples, and all the samples are going to have different means. But at least these means are going to serve as um, the point estimate to find the true mean. So you realize that the point estimate is most likely not the exact value of the population parameter, but very close. So it's going to be very odd that you find very polarized numbers. So in many cases, your means are going to be close to each other. So that's what we are thinking that it might happen. So after calculating point estimates, we construct interval estimates, and they are called confidence intervals. So that's a beautiful concept. Let me explain how it does work. So we have the point estimate for the population. I don't know mean. I don't know mu. All I have is a point estimate that I can use to find the true value of mu. So the point estimate, a single estimate for a population parameter, most unbiased point is the most unbiased point estimate for the population mean mu is the sample mean x bar, right? So if I want to estimate this population mean, all I need is the sample statistic, which is x bar, right? So this is the case. So how many people are in, let's say, Facebook, right? Millions and probably trillions or quadrillions number of people that are in the internet. So, well, I think the actual number is like a couple of billions. So just imagine that you want to answer a question. So in this case, a social networking website allows its user to add friends, send messages, and update their personal profiles. So the following represents a random sample of the number of friends for 40 users in the website. So this first person has 140 friends, the second have 105, the third 130, so on and so forth, right? Some of them don't have too many friends, some of them have so many friends. So in this case, 218. So how can I approximate the value of mu? So, well, first of all, I have a sample of 40 people. I'm gonna find the mean value of this sample. So we know that the mean of a sample or any population, we are gonna add all the values and divide it by the sample size, right? So in average, a person has 130 friends, 130.8 friends. And I mean, of course, this is an average because a person cannot be 0.8. So, so we have in average 130.8. So your point estimate for the mean number of friends for all users of the website is 130.8, right? So if somebody asks you how many people in average do you think that a person, how many friends in average do you think a person has in Facebook? You might say, well, according to this sample, I guess it's 130.8. So we might find that this is a value. But the question is, are you sure? So if we draw another sample, very likely this is not going to be 130.8. It might be 131, 133, 128. So we don't know. So this is for sure our best shot, right? So so what we are going to do is that we are going to create an interval. So I'm going to create a left endpoint and a right endpoint. So this value of my mean, of my sample mean, is going to be bounded by two different values, one that is at the left and one that is at the right. So how do I find these values? Well, that's what we are going to learn today. So we are going to find this interval estimate, right? So how, and that is the first question. How sure, how confident do you want to be that this is your true mu? Well, you cannot say 100% because once again, you take another sample and the value is going to be different. But you can say, well, I want to be 95% confident. So 5% mistake, well, I can take it. Or you can say, I am willing to be 90% confident. 90% confident. So I might be allowing myself to be wrong 10% of the times, right? So so that happens very often. This confidence level basically means how likely, how much of an error you can allow yourself. So in this case, so in many cases, if you are a researcher, so if you are a researcher, so confidence levels can be, for example, 90%. It can be 95%, or it can be 99%, right? Right? So that depends on how willing to allow mistakes you are. For example, you are analyzing how much people like the color blue. 10% might be fine. This 95% confidence level might be fine. Probably 95 might be appropriate. Most of the studies are based on a 5% confidence level. But let's say that you work for a company that produces medication. So you are 10% might represent people dying in big numbers. So 1%, 99% might be very appropriate for some type of studies. And even more for some like these clinical trials. So you are 99.9%. So that might be your confidence interval. So that might be your level of confidence. Why? Because you want to make sure that your study is gonna include the lowest risk that you can allow, right? So you are producing vaccines for 300 million Americans. So basically you need to be as accurate as possible. So a confidence level of 90% is gonna be catastrophic because that might not be appropriate. So in this case, a confidence level of 99.9% might be more appropriate. So my point is that this confidence level depends on the nature of the study and what the researcher wants to accomplish. So we are going to analyze this a little bit more. So let me just not make a big deal of this. So we have this interval estimate, so an interval or range of values used to estimate a population parameter. So this is going to be my point estimate. I'm going to build this left endpoint and this right endpoint, and then I'm going to make a statement. If I choose the 90%, I'm going to say I'm 90% confident that my mu lies between these 2 points. Where is it? I don't know. All I can tell you is that the true mu lies between these 2 points, right? So so that's something that we can do. We cannot say for sure where is the mu. We can say that we are confident 90, 95, or 99% that the mu lies between these 2 points, right? So so let me, before of that, explain what happens with the level of confidence. So I'm telling you that the level of confidence is how much error I am willing to take. So so in this case, the level of confidence is going to be determined by C, this letter. So every time you see C, that means the level of confidence. So the probability that the interval estimates contains the population parameter. So C is the area under the standard normal curve between the critical values. This is a very important concept because the first thing I'm gonna get is a confidence level. So so let me do this in a piece of paper. So so the first thing I know is that I have my normal standard curve, and the level of confidence is going to be 90%, right? So 90% of the area is going to be the confidence I want to take. So in this case, because this is symmetric, right? So I'm going to use 90% of this, right? So this is going to be the area that contains my level of confidence. So therefore, so 10% is going to lie in the 2 different tails, right? So, and because I have 2 tails, well, not me, but this thing. So we are going to divide the what is left. So remember that if I subtract this 90 from 1, which is the area under the curve, I'm going to get what is left from this. So 1 minus C is going to be what is left. In this case, is 10%, right? So, and because the area that I am going to be analyzing falls between 2 different points, so I'm going to call these points the critical points, right? So the critical point is nothing else but the C-score. Remember, I have an area under the curve, and I can determine the cumulative area here and the cumulative area to the left. So all I have to do is to find the values that represent the C-score based on this. So that is in order to find the C-score. So in this case, for example, so we have the 90% confidence interval, we have the 10%, which is 1 minus C. So here we have 5% of the area, right? So this area is 5%, and this area is also going to be 5%. Sorry for the bad drawing, but it should be something like this, right? I can fix it. Let me see. So something like this. So now this is 5% and this is 5%. This is 90%. So what I'm going to do basically is I'm going to find the cumulative area in these cases, right? So if I if I start from the beginning of the distribution to here, so the cumulative area is going to be 5%, which corresponds to the 0.05, right? So this is the cumulative area that includes from is to the left of this C-score, right? So if I keep going through the normal standard curve, this is going to be C plus, how to say? So if this is 9, if this is 5, so, and this is 90, so I say 90 and 5, here I'm going to have 0.095, right? So I'm going to find the C-scores that corresponds to these areas under the curve, right? So once again, I have a 90% confidence interval. So what is left is 10%, and it's going to be divided in the two tails. So the cumulative area until this critical value is going to be 0.05, and the cumulative area for the second is going to be 0.95. Is this clear for everybody? Is this clear for everybody? I will assume that is clear. And yes, thank you, Terry. So we have, it's a very simple concept, right? So we have the cumulative area. All we have to do is to find the C-score, and then we're going to be happily ever after, right? So this is one of the inputs that I need to find my my values, the value of mu, right? So let me continue with this. So we are gonna, so C is the area under the curve, on the standard normal curve. Remember, the 90% is gonna be located in the middle of the distribution. So that means what is left, I'm gonna distribute it in two parts. So in this case, the formula is 1/2 of 1 minus C, 1/2 of 1 minus C. So 1 minus 90% is 10%, so I take half of it. So this is 5% and 5%, right? So we are going to use the standard normal table to find the scores corresponding to the C-scores. But I don't like the tables. I am very much against the tables. Well, not really. So, but what I'm going to do is I'm going to use view zoom 150. So if I have a confidence level of 90%, right? So so one critical point is going to be 0.05, and the other one is going to be 0.95. So what I'm going to say is the C1 and the C2, right? So does anybody remember what is the code for if you have area under the curve, how to find the C-score? So remember, the C-score that we're going to find or we're going to pursue is going to be 0.05 and 0.95, right? So if you don't remember, I'm going to remind you. So we're going to do equal the norm, that is that IMV, and then I'm going to use the probability, right? This is my C-score for 1, and this is going to be my C-score for 2. Norm, that is that IMV, and then my probability for the second. So as you can see, there is nothing hidden from here. So let me make this more pleasant to the eye. So we have 1.645 minus and 1.645 plus. So so here, what happens here is the following. So we find that the C-score for here is 1.645 with the minus sign, and this is 1.645 with the plus sign, right? So that's very important because we need these values. We need the value of C in order to be able to find our confidence interval. We don't know yet how to do it, but this is something that we should know, right? We already know this, how to find these C scores. So, so it's very simple. The remaining area in the tails is 1 minus C. We divide it by 2, and then we find the cumulative area here, the cumulative area here, and then we use either your tables or you use Excel to find these values. So, so as I said before, we have the corresponding C score are plus and minus 1645. Always, all the times, we're going to use the positive value for 1645, right? Or the positive value for the C score. So if the level of confidence is 90%, that means that we are 90% confident that the interval contains the population mean, which we know is mu, right? So also, so we already know that we need the C score. So we are gonna find also the sampling error. So we need what is called the standard error. So so we are gonna find the sampling error, the difference between the point estimate and the actual population parameter. For mu, so the sampling error is the difference of the observed minus the hypothetical. So where generally mu is unknown, we don't know what is mu. And X varies from sample to sample. So we are in trouble because if I don't know mu, but also if I take different samples, all these values are going to be different. So all I can do is to find my confidence interval that allows me to be 90, 99, 95. Some books use 97, 98, some numbers that, well, it's just for the practice. So in order to find, so remember here, so we have this point estimate and we build the left and the right endpoints. So what we need here is the so-called margin of error. So the margin of error is gonna allow me to build the left and the right endpoint. So in this case, we have, this is the formula for the margin of error. So the greatest possible distance between the point estimate and the value of the parameter it is estimated for a given level of confidence. So this margin of error, nothing that you don't know. So this is C. So this is the value that we know how to obtain. And this is the standard error. And remember, the standard error is going to be equal to sigma divided by the square root of the sample size. So basically, we need very little information to determine the value of the margin of error. So once again, you draw a sample, and that sample is going to be very informative on how likely is that this sample reflects the population. So in this case, this is very, very interesting because in some cases, we don't have sigma. So sigma, remember, is the population standard deviation. But in some cases, we don't have it. We don't have the sample, the population mean, and we don't have the population standard deviation. So in some cases, we can use the standard deviation of the sample when my sample size is at least 30 or more, right? So we can use the standard deviation, but it's much better when we have the value of sigma. So sometimes called the maximum error or the error tolerance. So this margin of error, very important, that's gonna allow me to present my data and give a very good approximation on how likely is that data, so once again, reflects the population. So, so to make the long story short, so we are gonna compute the values here. So finding the margin of error, so we are gonna use the social networking website data and the 95% level confidence to find the margin of error for the mean number of friends for all users of the website. So assume that the sample standard deviation is 53. So here, that makes my life very easy. So I have here, I have here my confidence level, which is 95%. And I have my standard deviation, right? So in this case, I'm assuming that is sigma, which is 53, right? So I have a mean. So remember that my sample mean, my point estimate was something like 130.8, right? So 130.8. So I might be able to find the value very easily, right? So we have 95% of the distribution in the middle. So that means that if I divide what is left 5%, so 2.5% goes to the left, 2.5% goes to the right. So if I want to find the critical value, so I'm gonna look in the table for the 0.025 here, or I am gonna find the value here, which is the cumulative area until this point is gonna be 0.975, right? Why? This is 0.25, this is 2.5%, this is 95%, so the total value here is 0.975, the area under the curve. So I can use these values. I can find it in my computer. I can find the C-score. So remember, in order to find the margin of error, I need the C-score and I need the standard error. So so in this case, by doing this, I think I'm gonna use again. So here is 95%. So this point is gonna be 0.025. And the next point is going to be 0.975, right? So here I have the values. I already computed them. So I have the Excel code. So I just need to find here the margin of error, which is going to be given by the formula that we have, right? So in this case, so 95% of the area under the standard normal curve falls within 1.96 standard deviations to the mean, right, left and right. So you can approximate the distribution of the sample means with a normal curve by using the central limit theorem. You know how useful the central limit theorem is? I don't need to do anything because I am assuming normal distribution. I have a sample that is greater than 30, I have 40. So I can assume normal distribution. So I can use the C-score to find the values. So here, so I have the margin of error. So the margin of error is given by the 1.96, that is my C-score, the value of sigma, and then divided by the square root of my sample size. So we can do that. We can do the C-score. So in this case, the C-score is going to be this number that multiplies my mean, which is of my sigma, that divides the square root of 40, right? And then we close parentheses. So 16.4, right? So what happens here is I already have, so I didn't write the values here, but so here I have an X bar that is equal to 130.8. We have a sigma, because this is the population value. So this sigma is equal to 53. And we have a sample size that is equal to 40, right? So we need these values to compute the margin of error. So this is the margin of error. So now what is next is that I'm gonna build my confidence interval by subtracting the margin of error from my sample mean and then adding it on the other side, right? So my mu, the value of mu, is going to be between these two values. Once again, the question is, do you know mu? No, I don't know mu, but I can tell you with 95% confidence that my mu falls between these two numbers, right? So the probability that the confidence interval contains mu is C, which is the confidence level, right? So in this case, we are going to do, well, those are step by step. If you need some clarification of what you need to do, I think this is just for fun. But at the end, we have to find the left endpoint, the right endpoint, and then we have to make a statement. It doesn't say here, but we have to make a statement. So, so in this case, I am gonna find the left endpoint and the right endpoint. So here, I'm gonna use my mu, sorry, my X bar. I'm gonna subtract the margin of error, right? And then I'm gonna do again my mu, and my X bar, and I am gonna add the margin of error, right? So in this case, I build my confidence interval. So what happens here is the following. So construct a 95% confidence interval for the mean number of friends for all users in the website. So do we know exactly that this is the true mu? Well, we don't know, but I am 95% confident that my values fall between 114.4 and 147.2. So those are the values that we found. So we are going to write a statement that says the following. So because I'm very lazy, I'm not going to write it. I'm going to let you write it, but I'm just going to copy and paste it in my results. I think I'm going to write it. So where is this? Where am I? So I'm going to type here with with 95% confidence, you can say that the population mean number of friends is between 114.4 and 147.2, right? So once again, if somebody asks you, do you know what is the value of mu? You say, well, I don't know, but I am 95% confident that my mu lies between these two values, right? So this is very important because in many cases, that's the only way you can not prove, but give more certainty to your results. So confidence intervals are very helpful, and they provide this approximation, this inference for population when you don't know the population. So we have another case. So this is, well, and before we do this case, I just want to show you this one. So this is based on the exercise that you need to do. So very simple, very, very simple. So let me erase until here. So here, so we have data. So let's say that we have many, like not 13, but 130. We have a big number of data, right? So we don't know what is the population mean. So so in this case, I just put 13 because I'm very lazy. But just imagine that this is a big sample, and we are going to be able, as we know here, that when your sample is greater than 30, so you can use S instead of sigma, right? So just imagine that this sample is 130. So I'm going to find the mean. So this is two different values. This is cost A, cost B. I don't know what cost they are, but they represent cost of something. So, and I have these observations. Once again, just imagine that there are 110 observations. So one thing that I can do in order to do my computation, I'm gonna find the mean, which is not that one, is the average. So I'm gonna find the average. So I'm gonna find the standard deviation. So remember that in this case, we're assuming that this is the value of the of sigma. So so in this case, I'm gonna say STDEV. I'm gonna use the P just to make sure that we are using the population. And then I'm gonna find the standard deviation, right? So this is the X bar, this is sigma. So we can find the sample size. I can say count, and I can highlight my the range of values that I have. So I have 13 observations. So far we're fine. We have a sigma that is 7418, a standard deviation 3.94. We have, so the confidence coefficient. So once again, here we have the norm s.int function that we are going to use. So remember, we were doing the 95%. So I guess that was the first thing that we did. I think I erased it, but anyways, we can do it again. So so remember, we have the 95% confidence interval. Sorry for so we have the 95% confidence interval. So that means that the 95 area is going to be located here, right? So this is the shaded area. So we have the 95%. So 5% is left. So here I have 2.5%. And in the other tail, I have 2.5%, right? So the cumulative area here is going to be 0.025. And here the cumulative area is going to be 0.975, right? So I'm going to use this Excel function. So I'm going to say equal norm dot s dot inv. I'm going to type the 0.975, right? And that gives me a 9.60. Yeah. So this is the confidence coefficient. This is the C-score. So then we found the margin of error. So as you can see here, I did the same thing. I already, so we can do it again, but so we can do it again. Equal, so this is gonna be equal to the C-score that multiplies the sigma in this case, and is divided by the square root of my sample size, in this case is 13, and then that's going to be the margin of error, right? So here I am adding the margin of error. Here I am subtracting the margin of error. And of course, I can find some other values as the maximum value, the minimum value, the range that is between these two values. So the beauty of Excel is that it allows me to be as lazy as I can. So I just can highlight this area. I want the results for the next one. So what I'm gonna do is I'm just gonna drag this to the right, and bingo, you have all the values just by a click of a button. You don't have to type the values, the formulas again, because Excel recognizes that you are using this formula for the B, but here you are going to use it for the C. So all the values are already computed using the same thing, right? So so that's very nice. That's very nice. So this is one way to do the work. I'm going to show you something that is even simpler than this, right? So all you have to do is to make sure that you are using the right values, so you can find the correct results. So we are going to use this, the second one. I think so. Here, as you can see, this is a formula. This is a formula. So we are going to use, but I'm going to explain. So what we're going to do. So so very simple. We have this powerful tool that allows me to determine and make inference from my population using a sample. So once again, confidence intervals are very useful when we don't know the population mean. And that that doesn't find the population mean, but at least tells me that the population is within those boundaries. So so we went through this. So we found the confidence interval, and we made the statement. So make sure that those statements are accurate, because that is very important. That's how you report your values. You don't do this. You just report that with 95% confidence. You can say that the population mean number of friends is between 114 and 147. So once again, what is the true value? I don't know, but I can tell you I'm 95% confident that mu can be anywhere in this confidence interval. Okay. So we have this case when we have sigma. So in this case, I show this value, this example, because we were kind of using sigma and not sigma. So in many cases, when you have sigma, you can use the normal distribution. When you don't have sigma, so you can use S if you have more than 30 and approximate to the normal. But in many cases, we are going to do exercises when we know that we have a value that is greater than sorry, the sample size is greater than 30, right? So, or we know that the population comes from a well-known normal distribution. So in this case, solution constructing a confidence interval when sigma is known. So all we need to know is sigma, which is the standard deviation, the sample size, and the level of confidence, right? So in this case, this program is a little bit tricky. So as you can see, this Excel function is helping me to find the confidence, which is basically the margin of error, using the normal distribution. So when we have a sample that is greater than 30, or we know it's normally distributed, we can use the normal distribution. So that's what we're going to do here. We are going to use sigma, and we are going to assume that we have this normal distribution. So a college admissions director wishes to estimate the mean age of all the students currently enrolled. So probably this college director, admission director, doesn't have a database, and he wants to build a database, but he needs the information very quickly. So his boss is asking him, hey, what is the age of my students? I don't know, let me find out. So he takes a sample of 20 students, and the mean age is found to be 22.9 years. So, and then from past studies, he knows that the standard deviation is known to be 1.5 years, and the population is normally distributed. So he almost hit the big one here, because we have all the data that we know. We know that the population has been normally distributed. We have the population standard deviation, and we have data for the number of students, the sample size, and the average of this sample. So what we are going to do basically here is the following. So I'm going to recognize the values that I need, right? So first of all, here I have a 90% confidence level, right? So in this case, we are going to assume 90% confidence level. So that is going to be my C. So, so in this case, I already have the sample size. So in this case, I need here the sample size of 20 students. And I need the standard deviation that is 1.5, right? So 1.5. So the X bar here, I don't know why I put this in, should not be filled. So in this case, I have a X bar. So in this case is 22.9. So that is the mean age. So this is the number of students. This is my standard deviation. And this is my confidence interval. So in this case, we have to do a little trick here, because here, what this is asking me to do is not the confidence level, but is alpha. So alpha, as we can see here, is 1 minus C. We already know that. So when we are looking at the tables, or if we are doing this exercise here using this Excel file, this Excel function, all we need to know is the alpha that is found subtracting the confidence level minus 1. So in this case, 1 minus 0.9, right? So that is going to be 10%. So I'm going to use an alpha, not a confidence level, but an alpha. This is the trick to solve this case, right? So we are going to use an alpha that is represented by 1 minus confidence level of 10%. So in this case, I'm going to find, so in this case, I already, so if you can see here, so we already found the margin of error, right? So this is a margin of error that, so in short, when we are using, if we are using this, like we did it here, so we need to divide and find the how to say, find the critical values. When we are doing this, we don't need to find the critical values. All we need to know is to find, to know the confidence level and then subtract it from 1 to find alpha. So this exercise is asking me for alpha. So we can, I mean, so this is the idea. So I'm gonna repeat it. So we have an alpha, let's say that is equal to 1 minus 0.90, right? So just to make it more simple. So I have a standard deviation that is 1.5, and I was a sample size that was 20 students, right? So as you can see, my sample size is very small, but what makes the case for this is the fact that we have sigma. So the fact that we have the population standard deviation. So in this case, sample size is lower than 30, but we have sigma. So whenever we have the value of sigma, we can apply the normal distribution. So in this case, the margin of error is going to be 0.552. So if I type here the X bar 22.9, so I build this formula where I am subtracting the margin of error, and then I am adding the margin of error. So here we can say with 90%, so this is 90% confidence level, confidence that, how does, so 22.3, 23.5, yeah. So with 95 confidence, you can say that the mean age of the population mean, population mean age, so in this case age, of all students is between 22.3 22.3, and 23.5. 23.45, right? 0.5. Okay. So so in this case, this is very helpful. I don't know if in your example you have all this. It has to be here also with some color to differentiate that these are for, no, probably I will put the yellow, because those are formulas. You don't need to do anything. So here I ask Excel to subtract the margin of error, which is A2, from the X bar. Here I ask Excel to add the margin of error to X bar, right? So in this case, very simple. We are finding the values. So so that's a very good thing, because we don't get too distracted with so many procedures. I just identify the values that I need. So once again, here, we don't care about C, we care more about alpha. So alpha is gonna give me the margin of error without just basically doing nothing. So, so I need to know the level of confidence, and I need to subtract this from 1. So that's what I did here. So I found the margin of error. So let's imagine that I don't want the 90%, but I want the 99%, right? So the 99%, so we have, this is the margin of error. As you can see, the margin of error is wider. So that means that when we try to be more precise, the margin of error, the confidence level is wider. So for some reason in the paper that we were writing, so we found the margin of error, the confidence level, the confidence interval at the 95% level to be very wide. So so as you can see, the difference between the left endpoint and the right endpoint, they are very big. So that means that there is a lot of variation. So that's what your statistic is telling you. So that is a good number, but be aware that this is very wide. Okay. So is that good? Is that bad? Well, it's not. It's neither, because all you are saying is reporting your information, your data. Okay. So so how can we see this case? So just imagine that you have 100 different 100 different samples, right? So, well, in this case, let's put it more simple or simpler. So just imagine that you have 10 samples, right? So you choose a sample, take the mean, find the margin of error, and then build the confidence interval. Then you take another sample and do the same, find the margin of error and build the confidence interval. So if you are using a 90% confidence interval, that means that out of these 10 samples, at least 9 are gonna contain mu. Where is mu? I don't know. In this case, mu is exactly the value. In this case, it's not. It's kind of like a little bit to the right. This is a little bit to the left. This sample barely touches mu. So, but all these 9 out of 10 samples are gonna contain mu. This one does not contain mu. So that's how you are making sure that you are 90% confident that the mu is contained within any of these intervals. So your sample might be this, or might be this, or might be this, I don't know. But in this case, I can tell you that my interval contains mu. So the horizontal segments represent the 90% confidence interval for different samples of the same size. So in the long run, 9 of every 10 such intervals will contain mu. Which is mu? I don't know. It's still, I don't know. I am assuming that mu is here, but I don't know. All that I can tell you is that out of 10, 9 contain mu. So mu is a fixed number. It's either in the confidence interval or it's not. So in this case, 90% of the samples contain mu. So it's incorrect to say that there is a 90% probability that the actual mean is in the interval between 22.3 and 23.5. So what we can say that if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain mu. So that's the reason this is a very good statement, because you are confident that 95% with 95% confidence that the mean age of all the students, or the population mean for age in this school, is between 22.3 and 23.5. So this is the point estimate. So also we can do some other things. Let me see how we're doing with the time. That's fine. So this is also very important, because this is one of the list of the problems that we might have. So in some cases, let's say that this director, college admissions director, she chose a sample of 20. The question is that an appropriate sample? With this number of students, is this person gonna make a good inference of the case? Well, probably that's a good approximation, but probably is not exactly the best approach. So there is something that is called power analysis. So power analysis is something that we sometimes, or not we sometimes, we need to do at some point if we don't know what is the right sample size. So there are many things that we need to determine in this analysis. So for example, for an experiment, so we need a level of significance. What is the size of the population? So what is the statistics that we want to analyze? So this power analysis basically is something that includes this idea of building the right sample. So in this case, how do we know that we are using the right sample? Well, so we have a formula. So the sample size, so given a confidence level, so in this case, given this confidence level that we are converting into a C-score, so the minimum sample size needed to estimate the population mean is going to be given by this formula. And this formula is very simple. So we have the C-score, we have sigma, which is the population standard deviation, and it's going to be divided by the margin of error. So once we get this result, we just square it, and that's going to be the number of people that we might need for a study. So is that important? The answer is yes, because probably the 20 students was something that the guy came up for, like a emergency, that was a convenient sample. But if he wants to make a more, let's say somebody wants to know the mean age of students at Lehman College. I think at Lehman there are like 5,000, I don't know, many students. So you have to find the right sample size. So, and the sample size, once again, is going to be determined by the level of confidence that we want to achieve. So probably this level of confidence is going to be, so I want to be more accurate. So probably I'm going to need a big sample size. I want to use a 10%, probably my C-score, my sample size is going to be lower. So it also depends on the margin of error and of course, in the degree of variation of my population that I know. So, and also if sigma is unknown, so we can estimate the sample standard deviation. I use it if we have more than 30 students. So, so in this case, we can use those studies for our sample size. So in this case, we have this case. So you want to estimate the number of friends for all users of the website. So in the first case, remember we use 40. Is 40 a good number? Well, probably not. Probably if you are looking at Facebook, it's going to be a very big number. But so how many users must be included in the sample if you want to be 95% confident that the sample mean is within 7 friends of the population mean? So that is the margin of error. So here we have the confidence level, we have the margin of error. So it's within 7 friends up and down, and then we have a standard deviation of 53. So based on this, we know that the 95, this is my C-score. So we are going to use the positive, and we are going to apply the formula. So in this case, C is 196. Sigma, we don't have sigma. We have the standard deviation. This is a study with 40 students. So we can use this standard deviation of the sample, and we have the margin of error. So in order to make a more accurate, like for example, you can report your findings. Let's say that you are in the needs of finding some values, you can do some pilot studies, but then somebody funds your study. So you are going to be, you are going to have the freedom of choosing a larger sample size, right? So in this case, in order to do a more accurate accounting of values, so you need a sample of 221 people. So that's good. So just imagine that the number of people in Facebook is very big, so 220 might not be that bad, right? So when necessary, round up to obtain a whole value. So in this case, you can either use 220 or 221. I guess might be good to round it up to the next whole number. So you should include at least 221 users in your sample. Can you use more? Sure. I mean, maybe you find some funding from the Gates Foundation, or somebody who has money funds your research. So you can choose a wider sample, because in many cases, what happens is you have a study, right? So you give somebody a survey, a questionnaire to fill out. You pay the person for the time and effort, but then you realize that the person didn't respond to the survey the way you were expecting. So you are going to be losing people. So it also happens in longitudinal analysis when you are taking samples at different point in time. Like for example, this longitudinal analysis, somebody might be interested in following how well I'm doing while using Lipitor, right? So the producers, the manufacturers of Lipitor want to know how effective the pill is, so that they can take blood samples every month, every 2 months, to see how bad or how well I'm doing with my cholesterol levels, right? So that those types of longitudinal analysis sometimes need a wider sample, because some people are just not showing up. So you enroll people, and then the next less people are coming back to your study. So you are losing. So that is called attrition. So we will talk more about that. So in this case, the goal is just to show you how to build a confidence interval. And I guess I'm running out of time. It's 7:29. Let me stop the class and stop the recording.